at our table. We are going to start with cosecant. If we just go off the teacher, cosecant is the reciprocal of what? Sine. So I put the same main points up here that we did for sine. So sine of 0 is 0, so cosecant would be undefined. Sine of pi over 2, sine of 90 is 1, so cosecant would be 1. At pi, if you need to think about this. Sine is y over x, so 0, 1, so sine is 0, that means cosecant would be undefined. 3 pi over 2. Sine is negative 1, so cosecant is negative 1. Okay, 2 pi is back to the same thing as 0, so undefined. Now if I just plot these points, it doesn't tell me a whole lot. Undefined means asymptote, and we have a point at 1, undefined, negative 1, and undefined. What I'm going to do is let's just very lightly sketch in the graph of sine. Sine starts at 0, 1, 0, negative 1, 0. So sine looks like this. Cosecant is the reciprocal of that, meaning every time sine was 0, we get an asymptote. My high and low points stay. And then what the graph does is it's actually flipping it. So this little piece was going down. What's it's going to do now is up. So it's like an upward parabola and then a downward parabola, approaching your asymptotes. So the green is not really part of this graph. The purple is the actual graph of cosecant, but our strategy for graphing secant and cosecant, the easiest way we can do that is just graph our sine and cosine very lightly, and every time it was a 0, we'll put an asymptote, and then we'll just flip it away from the x-axis. And so then we're not really learning anything new, because we already know how to graph sine and cosine. The domain of this, let's put what x cannot equal. We get asymptotes, ... 0, pi, 2 pi, and that would keep going. So every multiple of pi. My range is going to be the opposite of sine. Sine hit everything between negative 1 and 1. Cosecant is hitting the opposite. It's coming from negative infinity. It stops at negative 1. Union picks back up at 1 and goes to infinity. So all that's happening here is we're alternating like upward and downward parabolas. So if we kept going, we would have one down here next. Is this an even or an odd function? Odd. Even means symmetric to the y-axis. This is odd, symmetric to the origin. So what that means is that cosecant of a negative x equals negative cosecant x. So far, everything except cosine has been an odd function. Any questions there? Let's graph secant. So if we start out 0, cosine of 0 is 1, which means secant would be 1. Cosine of 90 is 0, so secant would be undefined. At pi, cosine is -1, so secant would be -1. 3 pi over 2, cosine is 0, so secant is undefined. And 2 pi, we're back to 0, so we get 1 again. So just like we did on the last one, if I plot all those points, I've got zero, 1. Pi over 2 is undefined, so that's an asymptote. Pi gave me -1. 3 pi over 2 is asymptote, and 2 pi is back to 1. If we took a second and slightly drew the cosine graph, cosine starts at 1, 0, -1, 0, 1. So cosine looks like this. We're going to do the same thing we did on the last one. The high and low points stay, and then you're just flipping it away from the x-axis so it approaches the asymptotes. So the green isn't technically my graph, it's just what I draw to help me get my graph. It's just like cosecant. We just had those alternating parabolas. You know, if I continued my graph, I would get this parabola on the other side. I would get this piece. We're just alternating those. So the domain on this one, x cannot equal ... pi over 2, 3 pi over 2. What would the next one be? Pi over 2, and so on. The range is the same as cosecant. It's going down forever, so from -infinity to -1 with a bracket, union bracket 1 to infinity. Is this even or odd? Even. This one is symmetric to the y. That means if you have secant of a negative angle, you can just drop the negative. And it's the same as the secant of the positive. So secant and cosine are even. Everything else is odd. So we're going to graph these now, and we are going to work every problem. We'll just start out graphing the sine or cosine, and then get secant or cosecant from that graph. So 2 secant of 1/2 x. Amplitude 2. Period. Normal period for sine and cosine is 2 pi divided by the number in front of x. So 2 pi divided by 1/2 would be 4 pi. Count by period divided by 4 is pi. Do I need to do an interval in this one? You wouldn't have to. If you want to, you can anytime. Secant and cosecant, just like sine and cosine, we just set them up between 0 and 2 pi. So you multiply by 2, so we see we're going to start at 0 and end at 4 pi for this one. Okay. So first point is at 0, adding pi every time. Amplitude is 2. Okay. I usually have some people that are confident enough they can remember what secant and cosecant look like, and so they just graph it. Most people draw sine or cosine first. I have to be able to tell which part of the graph is your final answer. So that means if you want to graph sine and cosine first, you have to either really lightly draw it in, or erase it after you're done with it, or take a highlighter and highlight the final part of your graph, something so I know the difference between the two. If I'm graphing secant, that's the reciprocal of cosine. So I'm going to start by graphing cosine very lightly. So cosine starts at its high point and goes down. So there's my cosine graph. From that, I know every time cosine was 0, I have to put a vertical asymptote. We have asymptotes at pi and 3 pi. Our high and low points are going to stay. So I'm going to keep my points at 2 and -2. And then I just reflect the graph away from the axis. So just a nice curve approaching your asymptote. So you can, highlight that final piece if you want, or go back and erase the sine and cosine, or just make sure you draw this really dark, something so I can tell the final part of your graph. Is that one okay?
What? No, not at all.
Amplitude. What's this 1 doing? Period. Pi. So count by 2 pi over 4, or pi over 2. Okay, do we have to do the interval here? Yes, because we have something added or subtracted with our x. So, for sine and cosine, or secant and cosecant, you always do 0 to 2 pi. Add pi over 2 to everything. So we get pi over 2 to 5 pi over 2. So if we graph this, my first point on the x-axis is pi over 2. Counting by pi over 2, so the next one would be pi. 3 pi over 2, 2 pi, and 5 pi over 2. We're going up 1, so at positive 1, I'm drawing a dashed line. My amplitude is 3/2. So we'll be going 1.5 above and below that line. I am graphing cosecant, which is the reciprocal of sine. Sine always starts at its 0 point, which in this case will be on the dashed line. And then it goes up. Amplitude is 1.5, so I'm going to go up 1.5, so we're at 2.5. Back down to my 1, down to -1/2, and back up. So there's my sine. cosecant. Everywhere this is 0, which in this case the 0 is on my dashed line, we put an asymptote. Then these high and low points will stay, and you're just reflecting your graph. So my final graph there is just those two graphs. Do we need more of graphing these? You guys are comfortable with it? Just your sine, cosine, and your reflection? If you don't want any more examples of these, then I just want to do a couple where we write an equation for a graph, and then I'm going to give you plenty of time to work on homework today. So I want to write an equation for this. We did it with sine and cosine. What I am going to do is sketch in my sine or cosine to start. In other words, if I'm looking at this graph, it has an asymptote here, so I know my sine or cosine would have been 0. Then it would have hit 1, asymptote is back to 0, and so it would look like this. Is that green graph I just drew sine or cosine? Sine. So we are talking about the reciprocal of sine, which is cosecant. Okay. Amplitude of this graph. What is our amplitude? Where these points, they are at 1. So amplitude is just 1. We didn't move our graph up or down. We didn't flip. Period. How long did it take before this graph repeated itself? 4 pi. Okay, so we know you get your period by doing 2 pi divided by the number in front of x, and that had to equal 4 pi. So if I multiply over my b, divide by 4 pi, my b is 1/2. So this is y equals cosecant of 1/2 x. If I drew in my sine or cosine, this would be 0, 2. Is my 0 really at 0 this time? Where's the center of this graph? This is at this has point at 0 and this is a point at 2. So the middle of this is actually at 1. So this graph was moved up 1. That purple graph I drew in, is it sine or cosine? Sine. So the reciprocal of sine is cosecant. Amplitude. How far above or below that line do we go? 1. So our amplitude is just 1. Okay. I can do my period, but it's a little bit different here because my graph doesn't start at 0. This one has been shifted left or right. So let's use the interval to help us. This one starts at -pi/2. And ended at 3pi/2. But normal sine or cosine would start at and end at 2 pi. So we have to turn this back into 0 to 2 pi. So the first thing I'm going to do is add pi/2. Three pi/2 plus 1 pi/2 is 4 pi/2, which is 2 pi. These things are now correct. That means that this centerpiece is my angle. And then because my graph went up 1, I need a +1, either at the beginning or end. That's my equation. Do we need more? And I'm going to give you time to work and ask questions if you need it. So there's some matching ones in there, a couple fill